last topic was when infix notation is given, how we can convert it into postfix notation. Infix to postfix, and that is also using stack. So how many of you have still confusions on this topic? The conversion of infix to postfix. How many of you have confusions or in problems? Is there anyone who did this topic? Hello?
Yes, ma'am.
Should I repeat the topic again? Should I show you how we can convert an infix notation into postfix notation using stack?
Yes, ma'am, that would be helpful.
Yes, ma'am, it will be better.
Yes or no?
Yes, ma'am, it will be better.
Okay, then I'll definitely do it. So at first we can take an expression in infix notation. Okay. Suppose our expression is a plus b. After that, multiplication, then c, and then minus d division e, and then multiplication. We have taken one multiplication here, right? Minus, then division, again multiplication. After that, f exponentiation g. Okay, so this is the expression. Now how we're going to identify it, that which notation we use for representing it, infix, prefix or postfix. Obviously infix notation, right? Because all these operators are placed where? Between two operands. That's why the given expression is actually represented in infix notation. And if we want to convert it into postfix notation using stack, then how many things we need to have? At first, we need to use a stack, right? And then we can store all the operators here. So what about the operand? In this stack, we can store all the operators, including the parentheses, that is the left parentheses, and we need another column where we can add or we can scan the data elements of infix notation. So this is our expression q. That is, we can assign a variable to this infix notation. Q equals to a plus b into c minus d is division e, and then multiplication f exponentiation g. This is our infix notation. And we have a stack here and another column we need for the expression in postfix notation. So here we can use P for denoting the postfix expression. So we have to use an algorithm here, right? And the first step of the algorithm is add a right parenthesis at the end of the infix notation and add a left parenthesis where? At the top of the stack. Initially the stack is empty, so we can add a left parenthesis here. Okay, and now we can start scanning the element of the infix notation. Now first scanning process, or after the scanning process, we'll get a leftmost that is left parenthesis, right? So where we're going to add it? In this stack. Okay. After that, when we get an operand A, it will be stored in the postfix notation. What is the process of converting infix into postfix? At first, create this table where we can take 3 columns, one for the infix notation, another for stack, for storing the operator, and this is our postfix expression. Okay. So when we are scanning this infix notation, we can get 4 types of data element. One is operand. So when we are getting operand from this infix notation, just add it to the expression. Okay. And if we get operator, then we can store it in the stack, and we can store the left parenthesis inside the stack also. And for right parenthesis, we have to remove the operators from the stack. Okay, so now in third scanning process we got an operator, so this operator can be placed where onto this stack. Okay, and the expression has only one operand, that is a. And now the next data element is b, that is an operand, so that operand will be added to the expression. We can add that operand after a. So AB, there are two elements in this expression. Now, in our next scanning process, what we'll find? We'll get right parenthesis. Right parenthesis means delete or pop all the elements, that is operators, from the stack and add them to the expression. So we can see that there is a operator plus, and that is the topmost element of the stack. So we can add it to the postfix notation or expression. Okay, and after popping the element from the stack, if we get a left parenthesis, at that time we have to start this deletion operation here, then just remove that left parenthesis from the stack. Okay, now we can continue our scanning process. The next element is a multiplication operator, and that operator can be placed where? At the top of the stack, and one reason is the multiplication operator's precedence level is higher than the plus operator. That's why we can add it where? At the top of the stack. And this is our expression with three elements a, b, and plus operator. After that, we got an operand, that is C, and that operand can be added to the postfix expression. When the stack has four elements, two left parentheses, one plus operator, and multiplication. Please mute your microphone. Okay. So now we can add C where? After plus in this postfix expression. Okay, now after that the next element is an operator, so where we'll insert it, where we'll add it. This is our stack. Usually we place all the operators where? At the top of the stack. So can we make it the topmost element of the stack? Already the stack has some element and the topmost element is multiplication. Now can we place minus on the top of it?
No.
It's not possible, because multiplication operator has the highest priority. That's why we cannot place it. We cannot place minus at the top of multiplication operator. So now delete the topmost element from the stack, then add that minus operator as the new topmost element. So here, after removing multiplication, we can place minus, and that multiplication operator will be placed after C. So here we can write AB plus C multiplication. And then the next element is left parenthesis. We can add it to the stack. And the expression is same. A plus B, B plus C into, right? And now in our next scanning process, we got an operand D. So why we can add it? I'm just adding all the data elements in the same step. Okay, so here after getting D from the scanning process, we can add it after multiplication operator. Okay, now we can continue the scanning process. The next one is an operator. So where we can place it? In this stack. So this division operator will be placed after left parenthesis, and the expression will not be changed. Now the next step is again scan the infix notation, and we got E. Okay, so that will be placed here after D. And now after getting E, which element will get? Obviously the right parenthesis, and right parenthesis means pop the element from the stack. So how many elements we are going to remove? Only one element, because after this division operator, we can see a left parenthesis here, and we can pop the elements from the stack until we got a left parenthesis. So only this division operator will be popped from the stack and it will be added to the postfix notation. Clear? Is that clear?
Yes, ma'am.
Yes, ma'am.
Okay. And
Yes,
now
ma'am.
we can see a multiplication operator. So that multiplication operator now can be added here. Okay. After that, another left parenthesis, we can add the left parenthesis here, and an operator if will be added after division operator, then another operator. So that operator is going to be placed at the top of the stack. Okay. Then the next element is an operand. Just put it here in this expression, and then right parenthesis. So right parenthesis means remove the element, and we can remove only one element because after that we will get a left parenthesis. So just add that operator where into this postfix notation, and these left parentheses will be removed. Okay. Now after that we got another parenthesis. Hello.
Yes, ma'am.
Yeah, so where we can add it. Hello. Where we can add that element.
Madam, G.
In which steps we are now in? Here, isn't it?
Yes, ma'am.
So which operator should be written here?
Multiplication.
Which one?
Multiplication.
Very good, multiplication. I don't know why we have written plus here. We already added plus, isn't it?
Yes, ma'am. I was
No.
supposed to ask that.
So why didn't tell me that here
Got confused, ma'am.
it's correct, but here we cannot. Here it's also correct, but from this step we cannot write that plus. Okay, so one operator is still left to remove from this stack.
Minus.
After that, which operator is going to be placed here? Minus.
Minus.
This is the final step. And suppose you have some confusion, you have some doubts that whether you got the correct result or not. At that time, you can simply just convert this infix notation into postfix notation. But it's time consuming, so just try to be careful when you are solving it. Okay? Is it clear? In this way, we can convert infix notation into postfix notation. So do you want to try one? Do you want to solve another one?
Yes, ma'am.
Yes, ma'am.
Okay, so I'm just giving you another expression. Just convert it into postfix. So that is the infix notation, A division B minus C into D plus E. Just convert it into postfix notation. Okay.
Hello, ma'am. Done.
Very good. So can you tell us the expression that you got after the conversion?
Yes, ma'am.
Yeah.
The expression is AVC
A, B, C
minus D multiplication
minus then
D
D. Okay.
multiplication E
Multiplication D.
E
Multiplication E.
E
Okay.
plus division.
Is
Madam, I
this the
also
correct
think,
one?
madam, my answer is totally
Okay.
opposite.
Let me write your answers too. So
ABC
A,
minus
B,
C.
A, B, D
ABC minus
minus
division D.
division.
D.
After that,
D, madam.
Ma'am, D.
okay.
Multiplication E
Multiplication E.
plus.
Okay, so how many of you got this result and how many of you got the first one? First result.
Ma'am, I got the
Ma'am,
second.
my result is second one. My
Very good. So
ma'am,
this
my
is the
result
correct
second one.
result. This one is the correct result. Do I need to
Oh,
show you
oh,
the
ma'am.
process again?
I
I need
did
to
make a
solve
mistake,
it?
ma'am. Yes, ma'am. I solved it.
Okay. So that is our infix notation and this is the stack and this is the expression P. Okay. The first thing is we have to add a right parenthesis. Okay, then add a left parenthesis to that stack. Okay. Now our first data is operand, so add it to this postfix notation. Okay, and then we got an operator, so we can store it here in this stack, and this is our expression P. After that, we got a left parenthesis, just add it to the stack, and then another operand, so just place it after it. Okay, and then we got a right parenthesis, which means remove the element from the
state.
but where is B minus? Where is minus and where is C? It's not right parenthesis.
And there is minus.
You can take minus and C. Okay. Sorry for that. So the next one is actually minus. So we can add it to this stack. And this is our postfix notation with two letters or operands A and B. After that, we got another operand. So keep it where in this expression A, B, C. Okay, and then we got the right parenthesis, which means remove the data element from the stack until we got a left parenthesis. So here, after copying one element, we got the left parenthesis, so we can add only one operator here, that is A, B, C minus, and the stack has now two element, left parenthesis and division. Okay, now the next element is an operator, so can we place it here?
No, ma'am.
No,
No,
because
ma'am.
these both has the same precedence level, so just delete the topmost element from the stack, then place a new element at the top of the stack. So this is our multiplication operator onto the stack, and we can add division operator after minus. Okay, and then the next one is D. This is an operand, just add it after division. The stack will be same with two data element. And then another operator, so can we place it in the stack?
No, ma'am.
No, because multiplication has the highest precedence than the plus operator. So we have to delete this multiplication operator from the stack, then we can keep it here. And in the expression now, it will become ABC minus, then division D plus, sorry, multiplication. Okay, and then we got another operand E. It will be added to the expression. So A, B, C minus division D multiplication, and then we got a right parenthesis, which means just remove the operator and then ignore the left parenthesis. So we can add, okay, we didn't add E. This step we have to actually add E. So this is the expression in postfix notation. Clear? Is that clear?
Yes, ma'am.
Okay. So now can we do the opposite thing? That is, an expression is given in postfix notation, just convert it into infix. Can we do it? And here we have to transform the expression using stack. Okay, so now convert a postfix expression into infix using stack. So how we can do it? How many things we need? Hello?
Yes, ma'am. Isn't
Yeah, suppose a postfix expression is given and it is D, E, F, then division D, A, E, then exponentiation, again division B minus E multiplication plus. So an expression is given and find out its notation. It's in postfix notation, right? Because the operators, we can find the operators after the operand. That's why the expression is in postfix notation and we want to convert it into infix notation where the operators will be placed between the operands. Okay, so for this operation we need another algorithm. Okay, so at first we can assign an operator, sorry, a variable here, suppose p equals 2. Now we can write the expression. Okay, so we can store all the elements of the postfix notation into this variable p, and after that we have to add a right parenthesis at the end of this postfix expression. Is that clear? What is the first step? Add a right parenthesis at the end of the postfix expression. Okay, and in this operation we just need to scan this postfix expression and we need one stack. So this is our postfix expression that we need to scan. Okay, and this is our stack. So for this algorithm we have to follow some other rules. Suppose if we scan this expression, the first element that we'll get is an operand D, right? So if we get an operand after the scanning process, just add it to the stack. Actually we have only one structure, that is stack, right? We don't have any storage device, so we have to store all the operators and all the operands inside that stack. Okay, so when we get an operand, it will be stored in the top of the stack. After that we got another operand and we can add it after D. Okay, and we have another operand that is F. It will be also added to the stack D, E, F. And now we can see an operator comes here, right? That is division operator. So in this function the rule is, if you get an operator, just pop the topmost two elements from the stack and execute the operation or place that operator between these two operand. Suppose this is our stack and initially the stack was empty. After placing D, E and F, how many elements the stack has? 3 elements, but which one is the topmost element? F is the topmost element and E is the next to topmost element. So if we have to delete some data from this stack, we will delete the two topmost element, that is F and E. So F is the topmost element, E is the next to topmost element, and we are going to place that operator between these two operand. Okay, so in the next step we can write write D, and after popping these two elements, after executing the operation, we got E division F. This is infix notation, that's why the operator will be placed between the operand. And now we can continue the scanning process. The next element is an operand, so we can just store that operand after this operand E division F. Okay, and now again we got another operand that is A. We can simply add it to the stack. So D E division F, that's D, and we can add another operator A. Okay, again we got an operand that is E. It will be added where? Do we need to write the same steps again and again? Can we just add it here?
Yes, ma'am.
Okay,
Yes, ma'am.
so after getting E, now we can add E here. Okay, now the next element is an operator, and when an operator comes, just delete the topmost two elements from the stack. Now tell me how many data elements the stack has. D is one element, this E divided by F is another element, the third element is D, A is the fourth element, and E is the fifth element. So which one is the topmost element here?
E.
E. Okay, and the next topmost element, that is second topmost element, is A. So we can place the operator
Between those.
between these two operands. So in the next step we can write D and then E divided by F and then D A exponentiation E. Clear?
Yes, ma'am.
Now again we can start the scanning process, and again we got an operator. So now find out which ones are the topmost elements. A exponentiation E, this is the topmost element, and D is just next to topmost element. So we are going to place the division operator between these two data elements. After executing this operation on these two operand, now we've got the result and it will become one single operand. Okay, now we can consider D division A exponentiation E as a single operand. Clear?
Yes, ma'am.
Now again we can continue this process. Okay, now we got an operand. So B will be added here as the topmost element. Then we got an operator that is minus. So again, find out which one is the topmost element.
B.
B is the topmost element,
Before
and the second topmost element is which one?
the whole.
Division
by-
A exponent E.
Exponentiation E.
Did we? There was a mistake, and you didn't actually got that one. Can you tell me why we actually made the mistake?
The division before D.
Yes, ma'am.
Which one?
The division before. No, ma'am. Not sure.
Ma'am, the second topmost will be E division F, then D division A exponentiation E.
Then
The
division B. Actually, it's the problem that we didn't actually write all the operands here. That's why it's really safe to write all the things. Although it will take some time, but it's really safe if you maintain the whole procedure. If we write the whole thing. But I think there is a mistake. And since I didn't write all the operands here, okay, let me just find it out. So our first data element was D, after that E, then F, and then we got this division operator, after that D, and then we got A, then E, then we got the exponentiation operator. That means A exponentiation B. Okay, so we got D, then E division F, then D, A exponentiation E. Okay, then we got the division operator. So where we can place it? Between D and D, right?
Yes, ma'am.
Where we can place division operator? Here. After getting this division operator, we can place it here. Okay, now we got an operand B. Okay, so where we can add it? Here. B will be added here. Okay, so now the next one is minus. No, actually our process was right, isn't it? We
Yes,
didn't
ma'am.
actually make
Seems
any
so. Yes,
mistake.
ma'am.
Okay, that process was actually correct. So now where we can add that minus?
Ma'am, B is the topmost.
Very good.
The
Here,
before minus B.
paste here, right? Now this will become a single operand. Okay. After that, we can add another operand, that is E. Okay. Then multiplication. Now we can place multiplication here, because this is a single operand and the whole thing is another operand, so we can place multiplication operator here, and the last one is a plus operator, so where we can store it. After adding this multiplication operator, now this whole thing has become one operand. So where we're going to place it?
Before that.
Or D.
F after E division F.
Very good. After E division F, we can place plus. Okay, let me just explain the whole process again. When the operation is from
Haha, got the money.
we have an expression, so we have to scan the process, right? And after scanning the expression, we can store the operands and operator where? Into the stack. Okay, and the process is whenever you are getting operand, just add it to the stack, and when an operator comes, just pop the topmost two data element from the stack and then place that operator between them. So just try to solve another one, then maybe it will be clear. Okay.
Tanvir, sing louder, slight louder.
So this is a postfix notation. Just convert it into infix. Okay, using stack.
Name done.
Very good. So what is the result?
Ma'am, left parenthesis A
left parenthesis A
minus left parenthesis B divided C
let me just write B
divided C
divided C.
right parenthesis double.
Okay.
Another ma'am, right parenthesis.
After that,
Multiplication,
multiplication.
left parenthesis double,
Okay.
A divided K, right parenthesis, minus L, right parenthesis. This is my result, ma'am.
Okay. So how many of you proved this result?
I have got the same result.
You got the same result. Okay.
Yes, ma'am.
So is there anyone who got different result in this? Or do you need some more time to complete it? Hello?
Yes, ma'am.
Okay.
Yes, ma'am. Got same result.
Okay.
Yes, ma'am. My result is also same.
Very good. So this is actually correct result. So how we got the result? This is our postfix notation, that is P. At first add a right parenthesis here, and then we can scan the elements from P. And this is our stack. Okay, so at first we have an operand, just can add it to the stack, and another operand B, so it will be added after A. Okay, so A, B, and then the third data is also an operand, so A, B, C. Then the next one is an operator. Operator means topmost two elements from the stack and execute the operation B division C. So here we can write B is divided by C. Okay. And then the next one is another operator. So this is the topmost operator and this is the second operator. So we can place minus between these two operands. One is A and another is B division C. Okay. And then we got another operand A. So we can place it after this operand. And another operand, that is K. So we can store it where? After A. And then the next one is an operator. Now this operator will be placed between the topmost two elements, that is A and K. So here we can write A division K. Okay, and then the next one is L. So we got another operand, that is L. Okay, and then the next one is an operator minus. So where we can store it?
Before
Where we can
Before
store-
L.
For L.
Before L. So this is our topmost element and that is the next to topmost element. So now minus will be placed here. Then we can use the parenthesis. Okay. And after that we got another operator, that is multiplication. So where we can place it? Between these two operands. Now it is our topmost operand and that is the second one. So we can place multiplication between them. Okay. And when we got a right parenthesis, we can stop this process here. So this is our output. Clear?
Yes, ma'am.
Yes, ma'am.
Okay, then this is all about stack. In the next class, we'll start another data structure. Do you know which one? In the next class, we will discuss about very good queue, and that will be the last linear data structure. Okay. So, do you have any question in this translation? No. Okay. One, two.